Phil, it's devastating the industry, particularly the growers with the gold kiwi fruit are, in the North Island are devastated. Yeah.
I think that's maybe one of the aspects that people, generally don't understand, that this has been so devastating on the industry's premium product. Is that right?
Absolutely. That's it's been where most of the money's being made, and those growers have made huge investments into their gold kiwi fruit vines and the work and production of that, and it's and for them it's gone.
Now, Tom, at the moment, PSA is not here in Nelson, is that right?
At the moment, it's believed that it's not here in Nelson, and the Nelson Kiwifruit growers' main objective at this moment is to put as much money as they can into keeping any PSA getting into the South Island. They're doing that by restricting any budwood or pollen or whatever they can from the North Island in, and they appear to be doing a very good job at the moment.
All right. To the layman, can you explain to us just how this virus works within the plant?
It's a bacterial disease. Most people in the horticulture industry are used to dealing with fungal diseases. This is a bacterial disease. It's a very, very small molecular size. It's airborne, it's waterborne, and it's probably soil-borne, and it can live happily inside a plant. So it means it's extremely mobile, and anything that has any susceptibility to it, it's going to go for it. And if it gets attached to a plant that is susceptible, it's pretty dramatic in what it can do. It just attacks Ort16A as a plant.
Okay. And that's one of the issues here, really, isn't it? Because as I understand it, there are some strains of kiwi fruit plant that are reasonably resistant to the PSA virus, but the premium product, the 16A, hasn't got enough resistance to it and is being wiped out by this. Is that right?
That's absolutely correct. The Ort16A was developed. It's a wonderful, wonderful product from production point of view, marketing point of view, taste, keeping. It was a beautifully designed product for a world market. It appears now that maybe parts of that design of that plant left it a little bit susceptible to disease. Okay. But other certain kiwi fruit cultivars are not as susceptible, and the industry is open that they can use these cultivars that aren't as susceptible to bring back into the marketplace.
Now, Dave Leonard, you've discovered a product and you're bringing this in from overseas that seems to have some effect in the battle against PSA.
Yeah, Phil, we've developed a biological product, so it's a living range of bacteria where we apply it onto the plant and really try to protect the plant and outcompete the PSA disease on the plant to give it a bigger range of beneficial bacteria that so they can outcompete the bad bacteria. Yeah.
And so far that's looking pretty promising.
Yeah, it is. We've been involved in a number of trials now for quite a few months, in fact probably over the last year or so, from lab scale trials and petri dishes and things like that to full scale plant trials with KVH. So it is looking promising, but there's probably a long way to go. And I think, as Tom said, the Ort16A is a very difficult cultivar for any product, to be honest, to allow that plant to survive.
There's also the question of spraying the plants with antibiotics. There's been some talk that this isn't strictly legal, and also some comment that can't go on forever.
Well, they've made it legal in New Zealand over a fairly narrow window, so for kiwi fruit, so for all intents and purposes, for spraying it onto a plant prior to flowering, yeah, it's legal.
Well, it's lawful. It's not illegal, it's lawful. The industry fully realises that this may not be a long-term solution. The industry was between a very, very difficult situation that this antibiotic was the only antibiotic that at least could hopefully stop the spread of this disease. They allowed it to be used under very strict circumstances, under a very strict time frame, and that was agreed to by the industry. People who conformed to those practices in that time frame and did lawful work on it are fine.
All right, so you're importing a product and it's getting ready for distribution around the country. It's interesting that a Nelson company is involved in what is not necessarily a Nelson problem.
Yeah, I suppose a little bit. Tom and I have had our own individual businesses for a long time and had Biological Solutions for probably 4 or 5 years, and we're probably used to doing the majority of our work outside of Nelson region. So, dealing with problems within the industries and regions outside of Nelson is not new to us. And it's probably through the relationships we had with kiwi fruit growers up in the Bay of Plenty particularly that first got us involved with it.
Right. Realistically, can we keep the virus out of the Nelson area indefinitely, do you think, Tom?
Realistically, maybe not, but maybe if we're really lucky, vigilant, diligent, maybe if we get real lucky, maybe we can keep it out for 2 years. 2 years is a long time for a lot of people working on a problem to help resolve it. It will give them great breathing space, and it will give them a greater opportunity to decide where they want to go without the pressure that's being attached to the other growers in the North Island at the moment.
How does this plant shield product help in the fight against PSA?
It's been understood for a while. PSA originally showed itself to be a devastating disease in Italy, and it has been in Italy for a number of years, where it has just started to just wiped out the Hawes 16A variety in Italy mostly, and in France now. One of the growers over there was running a program of spraying biologicals in conjunction with low levels of copper to help control this disease. He was one of the very few people who managed to keep his crops together, get a crop off it and keep his vines in good enough health to keep cropping. So that led a lot of people to start looking at, is there a biological componentry to this disease? First of all, it's a biological disease. It's a bacteria. It's a biological bacterium. So trying to find a chemical to solve it is probably a nice thing to do, but I don't think that's going to work. I think if we're going to find something to kill it, we've got to look at a biological component.